All right, good morning. This is Monday, March 30th. We're going to be on day 6 of our AMI packets. I remembered that I have a program on my computer um, that it won't stop me at 5 minutes, so that way if I happen to go over just a little bit, it won't cut me off. So maybe that'll be more helpful this week. Um, so we are going to the AMP. Walmart is sponsoring a concert featuring 21 pilots at the AMP for a group of students, so the tickets are more affordable. Two tickets will cost $5. Create a ratio table which includes the cost per ticket, two tickets, four tickets, five tickets, 10 tickets, 15 tickets, 18 tickets, and 27 tickets. That's your table right here. And then you are going to create a coordinate graph using the data from your ratio table. So that graph paper that you received, you're going to need to use that to make a graph of this table. I would say make your tickets your x-axis and um, your cost your y-axis. And then you have a bunch of questions over here that you need to answer. So we'll go to the table now. So here's our ratio table. You're just filling this out just like you would any other ratio table by any other means. You can use repeated addition. You can multiply, divide. Um, you can you can make you can make visuals like just counting. For every two tickets, we know it costs $5, so you could draw that out. However you'd like to do that. I'm going to choose to do this by ways I've showed you in the past. So if I know that two tickets cost $5, what I can do is I can say, okay, well, I know that four is twice as much as two. So if I'm going from here to here, I'm really just multiplying this times two. Since I'm multiplying this times two, that also means I need to multiply this times two. Okay, so 5 times 2, move this down just a little bit. So if we do 5 times 2, we're going to get 10. So we know that the cost for 4 tickets is going to be $10. So we'll switch back to my pencil function. So it'll be $10. So now we're going up even more. If you notice, this is going from 4 to 5. There's not a great way I could multiply that, but I do know that I can multiply this times this. Right now, I've already seen the pattern. I have already figured out how much one ticket costs because I know if I take one away from here, I'm only left with one. One is half of two, just like two is half of four. So if I wanted to go back, I could also divide by two. So if I divide 2 by 2 up here, I'm going to get 1. And then if I'm going to divide, let me erase this because I was dividing 4 by 2. If I'm dividing 4 divided by 2, I get 2. And if I divide 10, if I divide 10 divided by 2, I get 5. So if I want to go back even further, like I was saying before, if I want to divide 2 divided by 2 to take a half of what 2 is, I know I'm going to be left with 1 for the cost of the tickets. And then if I divide 5, that's what I was going to do here a minute ago. If I want to do 5 divided by 2, I'm going to let you figure out what that would be. But that would tell you how much one ticket would cost. Once you get that, you can solve the whole table by just saying 1 times 5 is 5. So this number times 5 is this. 1 times 10 is 10. So this number times 10 will give you the price. 1 times 15 is 15. So this number times 15 is the price. And that's going to let you solve the entire table. From there, you're going to need to make a graph. You're going to need to make a graph of this. So what you could do here. I'm going to go to Desmos. let's start graphing. And so a minute ago, I said, why don't we use the tickets side as the X values, and we'll use the cost side as the Y values. So if I look on here and I say every number in this column is the X, I know that every number on the left side of my ordered pair here, like this, is going to be on this side. And then there's going to be a comma in the middle that separates them. And then the Y's will be on this side. So for example, my very first ticket price for X's is 2. So I'll go over here and I'll put 2. Okay. Go ahead and put my parentheses. Put my comma in the middle, and I'll go to the left side. If you notice, my next number is 4. So I can put a 4 here. I'm going to just keep on going down. And you can use this tool too. It's free. It's called Desmos, and it can help you check your graphing to see if it's accurate or not. But I'm just going to go down through here, and I'm just following these numbers. 5, 10, 15, 18, 27. So here I'm just going in here. I'm just putting the parentheses, and then I'm just inserting the X values right now. I'm going to stop at 15. You can go in here and do the rest. You're going to have to plot these anyway, and this will be good practice for you. But remember, Desmos.com, it's a free graphing tool that you can use. It's free to everyone. Doesn't cost anything. You don't even have to sign up. As you saw whenever I got in, I'll show you again. I just said Desmos.com, Desmos.com. Enter, and then you just click start graphing, and that's how I got there. So, all right. So now we need to put in our Y values. Our Y values are going to go on the right side of our comma right there. So let's go back. For the cost of the tickets, for 2 tickets in the X value, 2 X's, we have $5 for the Y. So here we're just going to put 5, and we don't need to put the dollar symbol since we're graphing. See how it's graphed that point there? And see, I noticed my point started way up here. So since my point started up here, I'm gonna just zoom out and kind of I'm just dragging my graph over because I know most of my points are gonna be up here. Let's look at the next one. We said that if 4 tickets cost $10, then how do you think the graph is going to move? Do you think it's going to increase, decrease, stay the same? What do you think? I think it's going to increase. Let's see. And it does. If I were to draw a line, I could draw a line straight up through there. So if you wind up with a point that's like, let's just say, I'm just going to guess on this next one, and I'm going to say 512. Okay. Do you see how this point's a little bit off? Because really the line should go right there. It should go right in front of it. Okay. That tells you that that point is not in the right place because it has to follow a linear pattern. Just going straight up like that. It's close, but it's not quite there. With the same thing, what if we let's put 20 on here, and I'm gonna have to zoom out to see it. See how that's way up here? Although it still is increasing, it's not gonna follow the linear path. If I continue to follow the linear path, it's gonna go like that. So it's way too steep right here. So we know 20 can't be right. If you complete your ratio table here, you should have a good graph that you can see though. Okay, let's go ahead and move on to the unit rate. We talked about unit rate in Unit 1. In order to find the unit rate, you're going to need to divide the cost by the amount sold. If you divide, when you solve this table over here, this is another way that you can check your answers if they're correct or not. If you do 5, whoop, still not great with drawing on here yet. 5 divided by 2, that's going to give you the unit rate because you're dividing the cost by the amount sold. Okay, you're dividing the cost divided by the tickets sold, and that will equal the unit rate. That's going to tell you how much one ticket costs. So this is really what you're doing, okay? Now, any number that you get over here should be able to be divided by any number over here. That's what I mean by 5 divided by 2. 10 divided by 4, whatever this number is divided by 5, whatever this number is divided by 10. When you find those numbers, they should all be the exact same amount because the unit rate doesn't change in this problem. It's going to be the same regardless. Okay? And it's going to be the price per ticket. It's going to be the price per ticket. You could even say the cost per ticket. Okay? The price per ticket. I'm going to erase this. It doesn't look very good. We're going to just put a dollar sign in here instead. The price per ticket. Price per ticket. So you're going to answer this, and here's a sentence frame that you can use. The unit rate is blank. I know this because, so that's a sentence stem you can use. But that's how you find your unit rate and justify it. Number 2 says, what is the greatest number of concert tickets that can be bought for $23? Justify your answer. There are several ways you can do this. You can go back to your table and you can just say, okay, well, I made the table, so I have the information there, and you can get the information from that. You can do repeated addition. So once you find the unit rate, you can just say, okay, well, I'm going to add the unit rate, and I'm just going to abbreviate unit rate with UR. I'm going to say unit rate plus unit rate plus unit rate plus unit rate, and you're going to keep doing that. Whoops, let me go back. Whoop, I messed up. Unit rate plus unit rate plus unit rate plus unit rate. And when you add these up, you want to get to $23. Hopefully you can find a total that will take you straight to $23. If you can't, you're gonna have to find the amount that's closest to 23 without going over, because let's say 15 tickets cost $24, and let's say 14 tickets costed $21.50. Well, $14 was only a dollar over. $15 was only a dollar over, but 14 was $1.50 less. But we can't spend more. We can't spend more than we have, and we want to know how much you can buy for 23. So just keep that in mind when you're trying to figure out how many you can buy for $23. You only have 23. So how many tickets can you buy for $23? You might have some left over. You might be right on the money. Multiply and divide. If we want to multiply and divide, this is going to be easy. Take your unit rate. Take your unit rate, whatever you found above as your unit rate, and you can simply multiply that times however many tickets you think that you need, and that's going to give you the price. Okay? It's going to give you the price. And then same thing if you want to divide. Well, if you want to divide the 23, because we know the tickets are $23, okay? And we want to divide. I don't have a division symbol, so I'm going to have to draw this in here in a minute. And we're going to have to divide that by how many tickets that we think will give us the amount of tickets sold. $23 divided by, and basically this is when you're dividing. So let's say, oh, I'm sorry, not the amount. I said that wrong a minute ago. It's 23, and you're going to divide that by the unit rate. I apologize. And that's going to tell you how many tickets. That's going to tell you how many tickets. So 23 divided by, let me draw your division symbol in here. Okay. But you're going to have the unit rate to do either one of those. The last one was make a table. You already have a table over here. I've given you an example of another one. If I said 3 tickets was $15, 12 tickets is going to be 60. How much is 6? How much is 9? That's just an example of another table. All right, write an equation that represents the relationship between the cost of tickets and the number of tickets. So X represents the number of tickets, and Y is the cost of your tickets. This is the price. This is how many you're selling, the quantity, and this is the price. There's two ways you can do this. You can do a division problem, which I've done in purple, or you can do a multiplication problem, and you can do it and I've shown you this one in blue. In these blanks, they're wanting you to write an equation that you can use. And it says write an equation. It doesn't specify numerical. It doesn't specify algebraic. Either one is fine with me. If you want to show me, if you want to show me how much that 5 tickets cost divided by the unit rate and how many tickets you receive, you can do that. If you want to actually show me how many, if you want to show me like an algebraic way to do this, what you're doing algebraically is you're putting an X or a Y, an X or a Y in these blanks. But you're going to have to find the unit rate either way, whether you're doing this numerically and showing me like how you found these costs on the table, or if you're just showing me algebraically for an equation that we could use to solve any of these, then you just need to use X and Y. So you might have an X here, you might have a Y here, you might have an X here, you might have a Y here. But I want you to think about, if we're going to divide, what do we need to divide the unit rate by to get? Like think about what's the independent and the dependent variable, because that's what we're going to be going to next. Okay? What goes here? What goes here? Is it the X or the Y on the left? Is it the Y on the right or the left? Okay? And I will tell you that if the X goes here, it's not going to go in the same place on the bottom one. If the Y goes here, it's not going to go in the same place as the bottom. They're going to be opposite, because remember, division is the inverse of multiplication, so they're opposites. They're opposites. All right, let's move on to number 4. I know there's a lot today on this one. It says the cost of the tickets is the dependent variable and the number of tickets is the independent variable. Explain why this is true. So I've given you an example of what an independent variable and what a dependent variable is. An independent variable is one that changes on its own without influence of another number. So examples of this are like maybe how many miles you drive in your car, or how many bags of Takis that you need to buy for your party. A dependent variable for these independent variables up here would be things like how much the gas cost for the miles that you drove. Okay, and then a dependent variable for the Takis that you needed for your party would be how much the Takis cost. It's however, if you have to buy 3 bags, it's going to cost more. If you had to buy 2 bags, it's going to cost less. If I drive 1,000 miles, I'm obviously going to need a lot more money than if I drive 500 miles, because that's half the distance. All right, you can explain how you know that this is true by using this sentence from here. This statement is true because, and you can explain how you know that um, your X is the cost of the tickets, the dependent. I'm sorry. Yes, the cost, which is the dependent, and the number of tickets, which is the independent. Last but not least, we have number 5. Explain how this scenario uses ratios to solve real-world problems. I've literally told you this is a ratio table here. Since this is a ratio table, that means the tickets to the cost ratio is 2 tickets to $5, or 2 tickets for every $5, or 2 tickets per $5. You could also say 4 tickets for every $10. And you can explain this by saying this scenario uses ratios to solve real-world problems by, and you can go on to explain how you know. Um, there's vocabulary words throughout this. There's dependent variable, independent variable, the word variable itself, ratio, ratio table. We have repeated addition, multiply, divide, table, equation. There's lots of vocabulary already in here. So just go through here and look if you need some math vocabulary to help you solve this. I hope this has been helpful to you this morning. If not, please reach out. And like I said, I'm using a different software tool today, so I think this will help um, not cut off after 5 minutes, especially with these activities that are a little bit longer like today. So I hope you have a great day, and I look forward to hearing from you soon. Bye.